Once again, we are going to establish the coordinates x, y of certain angles on the unit circle using a special right triangle. So the last time we do this, we are going to look at the angles pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And we're going to move over to page 8 to do this. Okay. All right. So as you can see at the top of page 8, our goal on this page is to come up with the coordinates x, y at the angles pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, so we've got the same kind of thing going on that we've done twice before. We've got the information on how to do this at the top. We've got the unit circle at the bottom, and we've got the point that we're interested in labeled. Okay, so we're going to be concentrating on pi over 4 here. I've labeled that point as point C on the unit circle. Okay, so again, all we're trying to do is establish the coordinates x, y of this point on the unit circle. Okay, what coordinates does this point have in the rectangular coordinate system? Okay, it's going to be done the same way that we've done the ones in past examples. Okay, all right, so if we go up here and we read, it says, if a diagonal is drawn at the pi over 4 radian mark, that is equivalent to 45 degrees, it will intercept the circle at point C. From point C, a vertical line can be drawn to the x-axis to create a 45, 45, 90 degree triangle. The relationship between the sides of a 45, 45, 90 degree triangle will help us establish the coordinates x, y of the point C. Okay. All right, so let's go do this. The only difference now is that it's going to involve a 45, 45, 90 degree triangle instead of a 30, 60, 90 degree triangle. Okay. All right, so here we go. We are going to build our triangle here in the first quadrant. Okay, so we've got the origin right here. Okay, so that's 0.00. Okay, so to construct our first triangle, we are going to draw a line from the origin to the point that we're interested on the circle. So we're going to go right here to the point represented by pi over 4 or 45 degrees. Okay, so there we go. Remember, this length is the radius of the circle. Okay, anytime you draw from the center of the circle to any point on the circle that is the radius, we know the unit circle has a radius of 1. Okay, the next leg of our triangle will come from starting at this point on the circle that we're interested in and drawing straight down to the x-axis. Okay, and that is forming a 90-degree angle when we do that. Okay, so the last side of the triangle comes from connecting the origin to this point where this point intersects with the x-axis. Okay, so there is your right triangle. Okay, again, here is the right angle. Okay, we know that pi over 4 is the same thing as 45 degrees. Okay, so since this angle right here is drawn at the pi over 4 or 45 degree mark, this is a 45 degree angle. And we know that the angles in a triangle have to add up 180 degrees. So 180 minus 90 minus 45 makes this angle right here a 45 degree angle as well. Okay. All right, so to establish the coordinates of this particular point on the circle of point C, we've got to come up with the lengths of the two sides for the triangle that we haven't found yet. We know the hypotenuse. We need the lengths of the other two sides. Okay, so we're going to use the special right triangle 45, 45, 90. Okay, so we're going to go and rehash what that relationship is. All right, so I'm going to go up here and draw a generic 45, 45, 90 degree triangle. Okay, so here we go. Here's your 90 degree angle. Say this angle is 45, this angle is 45 degrees. Remember how the lengths of the sides are related. Okay, so the hypotenuse is always going to be the longest side, and then the other two sides have the same length, okay, because they're both across from a 45 degree angle. All right, so what that relationship is, well, you look at the two sides across from the 45-degree angles, okay? They're gonna, like I said, they're gonna have the same length. We'll call that length A. And then once you know that, then you can get the hypotenuse. All you do is take the length of the one of the two other sides and you multiply by the square root of 2. And that gives you the hypotenuse, okay? So we're going to apply that relationship here, okay? So if we scroll back down, okay, we know that this is the hypotenuse, okay? The other two sides are going to have the same length, okay? We know that to get the hypotenuse, you have to multiply the length of one of the other two sides by the square root of 2, okay? So since the hypotenuse here for this particular triangle is 1, okay, we can solve for this, okay? If we know that the hypotenuse is 1, okay, that gives us this equation, okay? And we can solve for A, which is the length of one of the other sides, okay? So all I have to do here, since A is multiplied by the square root of 2, to undo that, I'm going to divide by the square root of 2. If I do it to one side, I have to do it to the other, okay? And then here, this tells us that A, which is the length of one of the other two sides, it's going to be 1 over the square root of 2. Okay, we need to rationalize the denominator. So multiply by the square root of 2 over the square root of 2. Okay, the side in question is going to equal the square root of 2 over 2. Okay, so that is the length of this side as well as this side. Okay, so this is going to be the square root of 2 over 2. Okay, and like I said, the work is above. Okay, and that's it. Okay, so now we should be able to get our coordinates. Okay, so remember, to get our coordinates, we need to look at how you would go from the origin to this point on the circle. You would first start at the origin and then travel in the x direction. Okay, so you have to travel a distance of positive square root of 2 over 2. So that is going to be the x coordinate here. Okay, let me write it over here so you don't confuse it with this point at pi over 6. Okay, so this is going to be square root of 2 over 2. Okay, and then once you get right here, you have to travel up this vertical distance. Okay, and then you reach the point. So this blue distance represents the y coordinate. Okay, that distance is also the square root of 2 over 2. Okay, and it's positive because we're in the first quadrant. Okay, so there are your coordinates for point C. Okay, so at pi over 4, which is 45 degrees, those are the coordinates on the unit circle. Okay, let me write up here just a reminder, since this was quadrant 1, both x and y coordinates have to be positive. Okay, all right, so now you can do like we've done in the other examples. Okay, you can take this triangle and do reflections in the other quadrants so that you can come up with the coordinates for 3 pi over 4 and for 5 pi over 4 and for 7 pi over 4. Okay, so I will go over to quadrant 2, okay, where we know the x coordinate is negative and the y coordinate is positive, and you can draw a similar type of triangle to get the coordinates at 3 pi over 4. All right, so to draw my triangle, I am going to start by drawing one of the legs from the origin to the point on the circle that we're trying to get the coordinates of, so right here, okay? So that is going to be our hypotenuse, okay? Because again, this red line, it is drawn from the origin to a point on the circle, so this is equivalent, the length is equivalent to the radius of the circle, that's going to be 1, okay? To get the next leg of the circle, we are going to draw from the point on the circle down to the x-axis, okay, and that's going to form your 90-degree angle. And then the last leg of the circle comes, or sorry, of the triangle comes from drawing from this point to the origin, okay? So here is your triangle for 3 pi over 4, okay? Here's the right angle, okay? 3 pi over 4 in degrees is 135 degrees. Okay, so again, what's going on here? If you were drawing the angle at 3 pi over 4, the angle would have to be in standard position. So the vertex would have to be here at the origin. The initial side has to line up with the positive x-axis. You would rotate counterclockwise So that would be 135 degrees. And you know that if you went the entire top half of the circle, that would be 180 degrees. So if you do 180 degrees minus 135, that's going to leave you with 45 degrees. And so that means that this angle right here is 45 degrees. Okay. Since there are 180 degrees in a triangle, take out, take away 90 degrees and 45 degrees from the 180. That leaves you with this remaining angle to measure 45. Okay. So you have another 45, 45, 90 degree triangle. Okay. Again, we are trying to come up with the coordinates of this point on the circle right here at 3 pi over 4. Okay. We need to establish the lengths of the other two sides on the triangle. We know the hypotenuse. Once we get the lengths of the other two sides, we will have our coordinates. Okay. Again, all you're going to do is apply the relationship in a 45, 45, 90 degree triangle as shown above here. Okay. We know that the hypotenuse is 1, okay? So like we did above here when we did the work, that means that the other two sides have to measure the square root of 2 over 2. Okay, so if we come down here, this length right here, okay, on the x-axis, that is the square root of 2 over 2. And then this vertical length on the triangle is also the square root of 2. Okay. Remember, when we're talking about lengths of a triangle, the lengths have to be positive. But when you talk about coordinates, that's when you get into positive and negative. Okay. All right. So to establish our coordinates here, okay, we need to look at how we travel from the origin to this point on the circle. Okay. So let's go ahead and travel from the origin, and in the x direction, we go this far. So we have to go a distance of the square root of 2 over 2. That is the horizontal distance we travel. Okay, so the x coordinate is going to be the square root of 2 over 2. But since we're in the second quadrant, the x coordinate has to be negative. So it's going to be negative square root of 2 over 2. Okay, and then finally from this point to get to the point on the circle, we've got to go up this blue distance. Okay, that blue distance is a length of the square root of 2 over 2. Okay, we're in the second quadrant, the y coordinate has to be positive. Okay, so the y coordinate will be positive. Okay, so there are your coordinates for 3 pi over 4, okay, which is the same thing, 45 degrees. Okay, again, you can go into quadrants 3 and 4, okay, and draw your triangles. Okay, I'll actually show you one because I've kind of been showing you first and second quadrants. I want to make sure you can draw something in the fourth quadrant or the third quadrant or the fourth quadrant on your own. Okay. Um, so if you went down into the third quadrant so that you were trying to establish what was going on at 5 pi over 4, here are the coordinates you're looking for this particular point. Okay, so all you would do here, you would do it the same way. You're going to start by drawing the hypotenuse from the origin to the point on the circle. Okay, we know that this distance has to measure the same as the radius of the circle, okay, because we're drawing from origin to point on the circle. And then this time you always draw, to make your triangle, you draw from the point on the circle back to the x-axis. Okay, so this time you have to draw up to reach the x-axis. Okay, that forms your 90-degree angle. Okay, the third side of the triangle, of course, comes from the from the connecting this point to the origin. Okay, so here's your triangle for the third quadrant. Okay, we know that this, like I said, is the right angle. Okay, when you're looking at 5 pi over 4, that is the same thing as 225 degrees. Okay, so if you were to draw 225 degrees in standard position, you would start at the positive x-axis and go all the way around to here, and that would measure 225. But then if you came back and you took out the top portion of the circle, which is 180 degrees, that would leave you with 45 degrees. Okay, so that's how you know that this angle right here is 45 degrees. Okay, so since we have a 90-degree angle, we have a 45-degree angle, there's 180 degrees in a triangle. This angle has to be 45 degrees. Okay, and again, we're trying to figure out the length of this leg and the length of this leg. You use your special right triangle to get that, okay? We know the hypotenuse is 1. We've already done the work. The other two sides are going to measure the square root of 2 over 2, okay? It's already labeled for this leg because this leg is common to the red triangle, okay? This length, this vertical length, is going to measure the square root of 2 over 2, okay? So now we know the lengths of the sides, so we can go ahead and write down our coordinates. We are in quadrant 3, where both the x and y coordinates are negative, okay? So basically here, if we're going to write this down, okay, to travel from the origin to this point on the circle, you're going to go in the x direction, you're going to travel square root of 2 over 2. That's the distance. The x coordinate in the third quadrant is negative. So this is going to be the negative square root of 2 over 2. And then finally, you're going to go from here to here to get to your point. You have to travel this vertical distance. It is also equal to the square root of 2 over 2. In the third quadrant, this y coordinate has to be negative, okay? So there are your coordinates for the point at 5 pi over 4 or 225 degrees, okay? Negative square root of 2 over 2, negative square root of 2 over 2, okay? All right, we can draw in the last triangle in the fourth quadrant, okay? This is going to happen at 7 pi over 4. 7 pi over 4 is equivalent to 315 degrees, okay? All right, so we're going to do this just like we've done the others, okay? We're going to start our triangle by drawing the hypotenuse from the origin to the point on the circle, okay? That means this will be a distance of 1, okay? Then you draw from the point on the circle up to the x-axis to form a right angle, okay? And then the last leg of the triangle comes from connecting the origin to that point, okay? So here's your right angle, okay? We know that the angle, if it's drawn in standard form or in standard position at 7 pi over 4 or 315 degrees, okay, it would start along the positive x-axis and it would wind all the way around until right here. That's a 315-degree angle. And so if you went 45 degrees more, 315 plus 45 would give you the full 360, the full measure of a circle, okay? So this has to be a 45-degree angle, okay? Since this is 45 degrees and this is 90, this has to be 45, okay? Since the hypotenuse is 1, use your special triangle relationship, okay? The remaining two sides have to be the square root of 2 over 2. We already knew that about the horizontal distance because this side is shared with the blue triangle. This vertical distance in green is the square root of 2 over 2. That's its length, okay? So now all of our sides are labeled, okay? So we can identify the coordinate right here at 7 pi over 4, okay? So again, we travel to go from the origin to the point. We first travel the x distance. That is the square root of 2 over 2, okay? And we are in quadrant 4, okay? In quad 4, we know x is positive, y is negative, okay? So your x coordinate will be positive, okay? Then once we go from the origin, travel the x distance, then we've got to travel the vertical distance down the point on the circle. That's a distance of the square root of 2 over 2, but in quadrant 4, your y coordinates are negative. So this is going to be negative square root of 2 over 2. And that is your coordinate. Those are the x, y coordinates of the point on the unit circle at 7 pi over 4 or equivalently 315 degrees. Okay, so we've established all of our coordinates using the special triangle 45, 45, 90-degree triangle. We've done the coordinates at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. If you flip back to the first page, you can look at the complete unit circle and compare our work to what was on here, and you should get the same